Guys, so welcome to our first online learning lesson, which is perimeter and area of a triangle. This is kind of like a demo. We're going to see how this goes. I would love your feedback to tell me if this was helpful, if you felt like having the answers pre-done and me just walking through it is helpful. Really, I'm just trying to adapt to what you all feel is best and helping you. So let's get talking. So first, really, this lesson is just talking about perimeter for the first half and then just area of a triangle. So some basic facts. First, what is perimeter? When discussing perimeter, we really talk about different shapes and figures and the distance around those shapes or figures. So when dealing with polygons, you're trying to figure out all the sides that make up the polygon, the lengths of those sides, and then adding them together to find the perimeter. So for instance, if it's a square has four sides, we would add all four sides of that square together and that would give us the perimeter. Here are just a few examples to really just solidify that we understand what perimeter is and how to find it. So the first one is right here, and we are dealing with Steph, and it says that here we are, Steph, needs to help her parents put a fence around their pool. So again, perimeter fencing makes sense. They want the fence to be square, okay, so key information, it must be a square, and want each side to measure 6 meters. Perfect. Now they already have 10 meters of fencing. We have to figure out how many more meters of fencing they should buy. Okay, so let's look over here. So we have our diagram, right? We sketch ourselves a square. We know properties of a square. All four sides are equal, and each side is 6. Therefore, all four sides are 6. So to find the perimeter, we would add all the sides together. 6 plus 6 plus 6 plus 6 gives us a total of 24 meters. Now, back to what the question was stating, we need 24 meters of fencing to fence around that pool. However, the parents already have 10 meters of fencing. So if we find the difference, which is 14, that's how much fencing they need to actually buy. So to answer this question, how many more meters of fencing should they buy? Your answer is going to be 14 meters. Okay, so that's kind of how we would implement a word problem into a perimeter. Pretty basic. Now, here are two more questions. Dealing with different polygons. The first one is a regular hexagon, so we know it has 6 equal sides, and the perimeter of that hexagon is 42 centimeters. We are asked to find the length of one side of that hexagon. So, since there are 6 equal sides that make up that regular hexagon, the perimeter is 42 centimeters, we know that all 6 sides must be the same length. So, we take our total perimeter, divide by 6, and tells us that each side length should be 7 centimeters. So our answer there is 7 centimeters. Okay, the one over here. The perimeter of the figure is 24 centimeters. What is the length of the missing side? So here we have our missing side. Have to find the length of that missing side. So similar, so we're just going to switch this up a little bit. This isn't a regular polygon of any sort. It's irregular. It's actually a 1, 2, 3, 4, 5-sided figure, so which makes it a pentagon. So we know if the perimeter is 24, and we have 1, 2, 3, 4 of the sides, we know if we add all 5 side lengths together, including the missing side, we can kind of create an equation. And that then helps us to then say, okay, combine like terms. We have 19 plus that missing side equals 24. Subtract 19 from both sides, and that missing side length should be 5 centimeters. So to answer this, we have the missing side length of 5 centimeters. Okay, so I hope perimeter is pretty laid out nicely for you. Just we're looking at the outside of the figure. Just make sure you're always reading carefully. And I think you guys will be pretty good with perimeter. Next, we're going to move on to area. So first and foremost, when dealing with area, we're talking about essentially like flooring, right? Filling in or shading in a two-dimensional or the inside of a polygon of some sort. So when we're dealing with area, it's 2 dimensions. So when we label with our units, it's always units squared. Whereas if you take a look here for perimeter, we were just talking about centimeters or meters. It's 1-dimensional. Area, on the other hand, is 2-dimensional. So we have centimeters squared, feet squared, meters squared. So just keep that in mind. So basic formula that we use in words is that it's the base times the height of the triangle divided by 2, which again, kind of relating that to a rectangle. A triangle is essentially half of the rectangle that it's inscribed inside of. So using b and h as our variables for base and height divided by 2, or sometimes you see it as 1/2 base times height. I prefer to go with this formula, but some people like to put the 1/2 in front and say you take the base and height and multiply it by 1/2. I like to multiply the base and height and divide by 2. Really up to you. But this is the formula that we're going to use. So all of the practice that we have, really the first step is write out your equation. So here it is. Right? And then just identify the base and the height. Now, for some of them, it's pretty straightforward, right? Here's our base, here's our height, right? We know that this is the base and the height because those are the sides that are perpendicular to each other. But in something like this, for the next question, it's a little more detailed in terms of now there's 3 numbers. And we know that the base and the height, those numbers, those segments must be perpendicular. So I know that 5 can't possibly be the base because it's not perpendicular to any other side. Whereas our height is 4 and our base is 8. Those are the 2 numbers that I'm going to use. So here's my base of 8 and my height of 4. Okay, so again, when you substitute it in, 8 times 4 divided by 2 is 16. So I'm just going to kind of go through, and again, we have here's our height of 10. And if you take a look, I kind of drew an auxiliary line to extend the base, because remember, your height is the altitude. So that's the vertex and must be perpendicular to the opposite side. We can kind of extend that side and say, okay, here's my height. And our base is over here at 8. So we have our 8 times 10 divided by 2, which is 40. Okay. And then just some more of the same types of diagrams. We have a base here of 18, a height of 6. So when we substitute it in, 18 times 6 divided by 2 gives us 54. Over here, height of 5, base of 4, same idea, just substituting in, dividing by 2 and to get 10. Base of 4, height of 8 gives us then 8 times 4, which is 32, divided by 2 gives us 16. Okay. Hopefully those are pretty straightforward, and we have one more practice here. And again, you know, there were 3 side lengths. We're going to focus on just the 2 lengths that are perpendicular, and there they are. Base of 12, height of 4. So 48 divided by 2 is 24. Okay. Now the second worksheet that we did attach that hopefully you tried was more of like an application of area and perimeter of triangles. We tried to kind of just include some previous lessons like maybe Hills and SAS or trigonometry and see how you did. So I'm just going to go through these, and again, I know all the work is here. I'm just going to explain the work and kind of assess. So to find the area of this triangle, it was, again, start with my formula. Area equals base times height divided by 2. So the good thing was, hey, look, got the base. The base is 4 plus 9, which is 13. Excellent. Now, so I filled in my base, and what was missing was the altitude. And again, altitude, I look at the picture, right? I have my big right triangle with the altitude drawn in. That means I am thinking of SAS here. So go back to SAS. Segment 1 over altitude equals altitude over segment 2. Remember, your 2 segments are here and here. So I substitute in my 4 and my 9 along with my altitude, leave it as A. Cross multiply, take the square root, and my altitude is 6. So I go here and I substitute it in. So now I know I can assess 13 times 6 divided by 2, and it gives us a total area of 39 centimeters squared. Right? Units squared because it is area. Now, number 2 was a little tricky. So number 2 asks you to find the perimeter of the triangle. So again, perimeter of a triangle, there are 3 sides, have to find the lengths of all 3 sides. So first off, we know we have the length of this side down here, which is 13. So perfect. I know somehow when I find the perimeter, 13 is going to be included. I was missing the 2 other side lengths, and I actually labeled them X and Y. Here they are. So to find these side lengths, we're actually going to use Hills. You could have used Pythagorean theorem if you wanted to take down the length of the altitude and do your two right triangles. I like to just use hills. I find creating those proportions and taking the square roots is a little bit easier for myself. So going over hills, it's the hypotenuse over the leg equals the leg over the segment that it's touching or projecting onto. So for our first variable x is our leg, so we put in x and x for a leg. Our hypotenuse is 13, so there it is, 13. And this leg is touching the segment of 4. So I'm putting in 4 here. So we cross multiply, take the square root. Now on your worksheet it says round to the nearest tenth. So I rounded to the nearest hundredth here and gave an approximation of 7.21. Similarly now for this other leg y, I use hills again. So the same hypotenuse of 13. My leg now is y. However, this leg projects onto 9. So cross multiply, square root, and we get approximately 10.82. So now I have all three side lengths. Y was 10.82, our hypotenuse is 13, and x 7.21. Add them together, 31.03, round to nearest tenth. Okay, 3, you tell 0 to stay, so our final perimeter is 31.0 centimeters. Okay, so not too bad. Little review of hills and SAS. And then the final question, again, a pretty basic question, but a little different in terms of now we put a triangle on the coordinate plane, a piece of graph paper. Now, what's important to remember about the coordinate plane is you're only allowed to count boxes vertically and horizontally, not on a diagonal. So for this here, we had to find the base, so it's allowed to count bounces. So okay, so 1, 2, 3, 4, 5 boxes, the base is 5, and the height. 1, 2, 3 boxes, there it is. So 5 times 3, which is 15, divided by 2 equals 7.5. Okay, and that was really it in terms of the lesson for today. So I'm hoping that the Khan Academy video, along with this answer key and the video that went along with it, my explanation, you guys feel good with this. And tomorrow we'll be moving on to a new lesson. And if this works, please email me so I know if I was talking too fast, if you'd like things done differently. We're trying to make this work for you guys. Okay, we'll talk to you tomorrow. Take care. Bye.